I want to talk quickly about function composition before we get stuck into this question 7 from 2017 exam 1. Say we've got a function, so let's go f of x equals root x and g of x equals x squared. So the function composition we want to make is f of g of x. So what we're going to do is put x squared into or on for x in this function. So that'll give us the square root of x squared. Now, everything that you've been taught really from now to, from 7 to 11 will tell you that the square root of x squared is the same as x, okay? So in theory, if I do this function composition, it should just generate the graph of y equals x. So let's just see what happens when I actually do it. Let's grab this here. All right, so here's something I prepared earlier. This is off GeoGebra here. What we've got here is f of x equals root x, g of x equals x squared. And if I do the function composition, I might get, well, I'm expecting to get the line y equals x. And note that I don't, but that is the line y equals x there. What happens is this part here doesn't continue down here. What it does is it kicks back up this way. This is actually the absolute value function, but don't need to know about that. All right, so what's going on? Well, it's true mathematically that those two are the same, but actually they're completely different functions. This is actually a new function, y equals x, or I could call it p of x equals x, all right? And what happens here is think about how this function will work. If I sub in -2 to it, it's going to go -2 squared is 4, the square root of 4 is 2, so it's going to give you a positive value. Whereas this one here, if I sub in -2, the y value will be -2 as well. So that yields that result of producing graphs that look like this, okay? So we're not allowed to do this move of simplifying it. When I do a composition of functions, what I'm going to do is just leave it like this, okay? All right, so that in mind, what I'm going to do, let's just get rid of all of that stuff there, and we'll go and work this problem and see how this works out. Okay, so what we've got first of all is this square root function here over this domain. So let's just do a quick sketch of it and make sure that we get this first question right, which is, a simple one looking at the range of the function. So what I'm going to do is bang this leftmost value into that. I'm going to do f of 0 equals the square root of 0 plus 1, which is the square root of 1, which is 1. So that's that point there. When x is 0, y is 1, and it will flick like so. Okay, so what it's going to do is produce y values from here upwards, or y values from 1 all the way through to positive infinity. All right, so fairly accessible question that, and I'd expect that a lot of the state got 1 mark on that one. Okay, so now what we're going to do is set up a function composition. So what we want to do is find the largest possible value of c, that is, restrict the domain of this function here, so that the range of this function is a subset of the domain of the other function f. So recall that the domain of f, the square root function, is 0 to infinity. Okay, where did I get that? I just got that from there. That's the domain of f. Okay, and what we want to do is make the range of g a subset. So we want it to be this. Okay, so clearly at the moment it isn't, or it doesn't have this range. Okay. Right, so let's just think about what's going on here. What I want to do is produce the lowest y value that I can. That is, I want to produce the y value of 0 and upwards. So what I'm going to say is, like, I want a y value of 0. So I'm going to let g of x equal 0. So I'm going to say 0 equals x squared plus 4x plus 3. 0 equals, quick factorize here, x 1, 3, x plus 1, x plus 3, x equals -1, x equals -3. All right, let's just think about what that parabola actually looks like. There's -3 and there's -1. All right, parabola looks like so. Don't need to worry about y-intercepts or anything like that. Now, what is this domain suggesting? That we're going to swing in from negative infinity. So we're coming in this way, we're producing y values up here, all the way down to this point here. Okay, the y value is exactly 0 there. Now, after this point, the y value dips below 0. Okay, and that's going to be, or that's going to mean that the range of this function here is not a subset of the domain of f. Okay, it's going to produce y values that are lower than 0. So actually, we don't want these values here. Okay, we don't want them, and subsequently, we don't want that part there. We want the values from negative infinity all the way up to negative 3. When we terminate it there, we're going to be able to produce 0 to infinity y values. Okay, so in this case, c is going to equal negative 3. Okay, so let's just update that. That's negative infinity all the way up to negative 3. All right, so down to this question here. For the value of c found in part B1, state the range of the composition. Okay, so there's a few ways of doing this, but what I'm going to consider is first of all the domain of G. That is, what values will this accept? Okay, so again, we look at this here. Oh, that's the one we just set up. It's 0 to negative 3. Infinity. Negative infinity all the way through to negative 3. So that's what it's going to accept. Okay. Now what I'm also going to do is just have a quick look at what the function composition looks like. So I'm actually going to do the composition. So f of x equals the square root of x plus 1. I'm just rewriting these because I don't want to scroll up and down. And g of x equals x squared plus 4x plus 3. Okay, so let's do f of x squared plus 4x plus 3 equals the square root of x squared plus 4x plus 3 plus 1 equals square root of x squared plus 4x plus 4, which is the square root of x plus 2 all squared. That's a perfect square. All right, so again, you want to avoid now saying, oh, this is the same as x plus 2, okay? Whilst mathematically that's a good simplifier, that works. Remember, this function here is a linear function that will go through 2 and look like that, whereas what's going to happen with this one here is it's actually going to sort of bend upwards somewhere, okay? So we've got to remember that we're not allowed to do this simplify, and we're going to leave it as that, okay? All right, now let's consider what's going to happen here. So what we're going to do is I'm going to let x equal negative 3, or sub x equals negative 3 into f of g of x. Okay, so let's go f of g of negative 3 equals, okay, so I'm going to go square root of bracket negative 3 plus 2 all squared, square root of negative 1 squared, which is 1. Okay, so what's going to happen is at this point here, when x is negative 3, okay, the largest value in the domain it's allowed to be, I'm going to produce a y value of 1. Right, so again, let's just consider that. So when x is negative 3, y is 1. Okay, all right, now what's going to happen here is I'm expecting to get this thing to happen. I'm just going to check out whether negative 4 is indeed going to keep this moving upwards. Okay, so let's do, or just quickly work out what f of negative 4 will be. I'm just trying negative 4. You could try negative 5 or negative 6 to confirm that it will go like this. So let's go negative 4. Negative 4 plus 2 is negative 2. Negative 2 squared is 4. Square root of 4 is 2. Okay, so if I drop negative 4 in, I get a larger y value. So it is indeed, conforming to this behavior here. So that means that the lowest y value I'm able to produce is 1, and for values that go or approach negative infinity, I'm going to keep producing higher y values. So my my range of the composition is 1 to infinity. So let's just say ran f g of x equals or is this amount here. Right, so the last question was this one here. It was another function composition, and what it asked for is the range of this composition. Right, so let's make the composition, and let's note that the domain of h of x, well, it's a parabola, okay, this is what it looks like, that, and so it has a domain that is the set of all real numbers. Okay, so let's actually do the composition, which is f of x squared plus 3 equals x squared plus 3 plus 1, all square rooted, which is x squared plus 4 square rooted. Okay, right, so again, just remember that this, when the function looks like this, it's going to sort of do this kind of thing. It's going to have a situation like this. Okay, so recognize that that is going to produce a graph that looks like that. So what you want to do now is remember this is asking for the range. Okay, so the domain is a set of all real numbers, and it will produce the resulting function will be the domain will be the set of all real numbers. But we're interested in the range. That is, what is the lowest y value I can produce, and what is the highest y value I can produce. I'm going to take a punt and say that it's x. Let x equal 0. So if I put 0 in there, I've got 0 plus 4 is 4, square root of 4 is 2. Okay, so when x is 0, y is 2. Okay, and what I'm anticipating to happen now is that we're going to get this sort of thing happening here. It's going to go upwards on either side. So I'm just going to quickly try that out. 1 squared is 1, 1 plus 4 is 5, square root of 5 is a number that is larger than 2. All right, so it definitely goes up that way. And we can also see that negative 1 squared is 1, 1 plus 4, it's symmetrical over this side or symmetrical across the y-axis. So certainly the lowest y value I can produce is the 2 that I got out, okay? Therefore, the range is going to be from 2 upwards, or the ran f of h of x is 2 exactly, all the way up to positive infinity. Right, so there it is, and I hope you went all right with that question. Do this question a number of times. Picture the functions. Okay, you need to draw these things to work out exactly what's going on, and probably be a little bit neater than me, as I've done a lot of annotating here and tried to explain exactly what my thinking was to you guys. But I would need to clean this up a fair bit to make sure that my answer was really clear and explained, in a good manner.